All right, so what we've got again is we've got f of x is x to the 6. All right, so what we're going to do is we're going to find f sub c, or f sub 1. We're going to determine f prime sub 1. We're going to determine f double prime sub 1. And then we're going to determine f triple prime sub 1. And we're going to substitute into our definition of the Taylor series that I have up here. All right, so f sub x was x to the 6th. All right, so f sub 1 would just be 1 to the 6th, which is just 1. All right, so that's just 1. And f prime sub x, that is 6x to the 5th power. 6x to the 5th power. All right. And f prime sub 1, that would be 6 times 1 to the 5th power, which is 6. F double prime sub x, would be 30x to the 4th power. 30x to the 4th power. F double prime sub 1, sorry about that. F double prime sub 1 would be 30 times 1 to the 4th. That would be 30. All right, sorry about that, getting cut off a little bit. All right, and then let's go the third derivative, f triple prime sub x would be 120x to the 3rd. 120x to the 3rd. And f triple prime sub 1 would be 120. All right, so we're going to use those to substitute into this definition of the Taylor series that I have right here. All right, I'm going to substitute all of that into there. All right, so let's take a look. Let's take a look at what we got here. All right, so let's keep going. So what I have here, once again, I'll rewrite it one more time. I've got P sub x is, we've got f sub c over 0 factorial, we did that already, plus f prime sub 1 for our problem. In general terms for c, you put a c there. That's raised to the 1 over 1 factorial. And then you have f double prime sub c times x minus c to the 2nd power. That's over 2 factorial. And then let's go one more. We've got plus f triple prime sub c times x minus c to the 3rd power over 3 factorial. All right, so let's begin to substitute like we did last time. So the function that we're looking at, we've got f sub c, we've determined that already, which was 1. So we got 1 times x minus c to the 0 power, that's just 1. That's 1 over 1, so we get the 1 there. Sorry about that. So we get plus f prime sub c. We figured that out already. F prime sub 1, we figured out was 6. So we got plus 6 times x minus 1 to the 1st power. That's over 1. All right. So now what we've got plus, all right. So we got plus f double prime sub c. That was 30. F double prime sub 1 is 30. We got x minus c, or 1, to the 2nd power over 2 factorial, which is 2. And now we have plus f triple prime sub c. That was 120 plus 120 over 3 factorial, which is 6, times x minus 1, and that's going to be to the third power. All right, so this simplified. The function that represents this x to the 6 would be p sub x is equal to 1 plus 6 times x minus 1 plus 15 x minus 1 squared plus 20 x minus 1 cubed. All right, and that could go on and on and on. This could go on and on and on. All right, and to the degree that you continue to add here, you know, that's only a third degree polynomial, but the more terms that I have, the better the approximation is of this original function here, f of x equal to x to the 6th power. All right, so let's say there's a problem. You have f of x is e to the x. All right, let's see if we can get a blank sheet of paper. All right, so we've got f of x is e to the x. F of x is e to the x. All right, so that's your very, very common function. And let's say we have already, earlier in the show, we've already rewritten this as a Taylor series. And what we said was that we did this already. Okay, we did this right here. We already rewrote this as a Taylor series. 1 plus x squared over 2 plus x to the 3rd over 6. We've done that already, so I'm just going to rewrite what we've already done. All right, so we got 1 plus x plus x squared over 2 plus x to the 3rd over 6. We did that already. All right, we did that already earlier in the show. What I'd like to show you is sometimes I've seen problems on the AP exam where they'll ask you to rewrite f sub e, f of e to the, let's say 2x. All right, f sub e to the 2x. All right, so we're going to end the show with this. What I'd ask you to do here is to be able to see that we've already done a Taylor series for e to the x. So what you would do here is just substitute the 2x wherever you have x here, and that's going to represent an approximate Taylor series for e to the 2x. All right, so this is e to the x, what I've got here. But if you wanted to rewrite e to the 2x, f of x is equal to e to the 2x, you would just make a substitution. So we've got p, the 2x, you would say 1 plus, all right, 1 plus 2x, wherever you have x, you substitute 2x, plus 2x squared over 2 plus 2x cubed over 6. So what I'm really trying to say to you is to figure out what the Taylor series would be for e to the 2x, you just make a substitution 2x wherever you have x in the Taylor series for the e to the x function. If you wanted to figure out what the, well, let's just keep going. All right, so we only have a little bit of time left. So you'd end up with 1 plus 2x, and you would square 2x, so you'd end up with plus 4x squared over 2. All right, plus this would end up being 8x cubed over 6. Just distributed the 3 there. And you'd end up with the approximation for e. Let's just put in a sort of approximation symbol here. An approximate value of e to 2x. We only have 1 minute left. You'd end up with 1 plus 2x plus 2x squared plus, each of these is divisible by 2, 4/3 x to the third, and you could take that out as much as you'd like. And the more of these terms you have, the more accurate your answer would be.